So, um, all right. I don't know if you're here to kind of just see what's going on, Elizabeth, or you got any questions, but if you do,
Yeah.
fire away.
So after the test, I was just like looking over it, and I think I'm like misunderstanding momentum, and especially with like the first question of chapter 7. I'm a little bit maybe it's also like speed and velocity.
Okay.
I'm just a little bit confused on the differences between like energy and momentum and how they correlate and like their similarities and how that goes back to like speed.
Okay. Yeah. I guess I'll start by saying that's normal. A lot of students have a lot of troubles with momentum and energy, and I think probably because it is something you can't, physically touch, and so they want to think of it more in the abstract, and they kind of overlook that there are two quantities that have to be true at the same time. Let me see if this helps. I'm gonna maybe draw some pictures. So I'll share my screen here. You can go to my camera here. Turn on the Bluetooth here. Give it a second. But I don't know if it's any comfort to know that it's normal that that's what happens with students. And it's interesting that, and I think because velocity you can kind of see, and this is why I wanted to draw a picture. So if I said, okay, let me look at quantity number 1, quantity number 2, and quantity number 3, and just kind of going in the order that you've learned. You learned like speed, but then you also learned momentum, and you also learned kinetic energy, or you are learning kinetic energy. Okay, and all of them involve speed, and so it can easily get swamped in your mind as one and the same, because obviously then if you change the speed, you change all of these, but they're not quite the same thing. And so speed, I think is a little easier for students to grasp because they see a car. There's the car, and then the car moves to here. Didn't really match my cars there, but as the car moves from point A to point B, there's this distance it travels, something I can like physically touch and see. I could reach out with my left arm and then my right arm and say, okay, they're separated by a distance. I see that. But what you can't see is that as this car is moving, it has something called momentum. And that's where we learned in chapter 6. It's a product of the two. And it would almost be nicer if like momentum had a color to it. And so you could say, well, the car's moving slow, so it's red. And then it goes a little faster, so now it's green. And now it's going a little faster, so it's blue. And you can actually say that the car now has different amounts of momentum, something I can actually see with my 5 senses. And momentum is something that humans can't see with our 5 senses. And so we just kind of have to use a little bit more of the mathematics to say, okay, the car has this thing called momentum, and I can't touch it or feel it or see it or taste it or smell it, but it's there, okay, and I can calculate it. And then it's got this other thing too, okay, so this car, besides having this momentum, also tied with the speed is its kinetic energy. So I wish that was maybe kind of a smell. And so the car's going slow, so it has a low speed. It's going slow, so it has a red color. And it's going slow, so it smells like an orange. But you see, it's red and it smells like an orange at the same time. These are two separate quantities, two things that we as humans can't detect with our senses. But if we could smell it and see it, maybe that would clue us in that these two things are there at the same time, and that they need to be dealt with separately as well as they are occurring at the same time. So when you go to write out a set of equations for conservation of momentum, that's true, but at the same moment you would have a set of equations for conservation of energies. So if the car went faster, now the car is going faster, and so it's going faster. Well, now it looks blue to my eyes, but instead of smelling like an orange, it smells like a strawberry. And I hope I'm not being too silly, but I'm really trying to see that these are two different senses, two different things that you would detect at the same time, two different things that would be going on at the same moment, but yet they are different. And my analogy is not so perfect because color and smell don't perfectly go together, but these are tied with velocities. And so I would have to, if I had the car moving along and it collided with something, and this is probably the type of problems you're running into, I would say something like, okay, the momentum before equals the momentum after, but also I have a set of equations that says the energy before equals the energy after. And so I would be doing both of these at the same time. I could think about the energy associated with the car, but I could also think about the momentum associated with the car. And of course, both of those are tied to the speed.
So specifically for the first question on chapter 7, it asks if a system has zero momentum, does it necessarily have zero kinetic energy? And the answer is just, I thought they would kind of go if there was momentum, there would be kinetic energy, but it's not like that. So something can have speed but not have momentum. So that's kind of where I'm getting confused.
Right. Okay. So good. I'm glad you asked a specific question because, again, it ties in with this, but what they're getting at, if you only looked at one object, your answer would be no. If you have this, you got to have this. Okay. But when you have a system of objects, then watch this. In here, you could have positive and negative numbers because an object could be going in a positive and negative direction. So an object could be going in the positive direction and have positive momentum. And then a second object could be going in the negative direction and therefore have negative momentum. So when you take a positive number and a negative number and put them together, you could come up with zero. And they're trying to get you to see that would never happen with kinetic energy. Kinetic energy is a square. So if the speed is positive or negative, once you square it, you only end up with positives. So if you take two objects and they're both positive and you add them together, if one speed's positive and one speed's negative, once you square them, they're both positive. And so they're trying to get you really to focus on the fact that momentum can have positive and negative numbers. And so like two cars approaching each other might actually have together collectively no momentum. In other words, zero momentum does not mean zero speed if you're talking about two objects. Now it does if you're talking about a single object. And that's really the subtlety difference here. Whereas then, so I put it this way. So this might have positive momentum and this one might have negative momentum. So one's greater than zero and one's less than zero. But when I go to do the kinetic energy, they are both greater than zero, and so the total kinetic energy is always a positive number. So kinetic energies, this was a weird question in the sense that it was trying to get you to see kinetic energies will never be negatives. They will always be positives. Momentums can be positive and they can be negatives. So if you allow for positives and negatives and you allow for more than one object, then something like momentum could actually come out to be zero, yet they're moving. And then kinetic energies would not.
I think, yeah, that makes sense. I think I like the system part of it, I would like just an object. That's different.
Yes, yes, yes. And
obviously, but like,
yeah, right. And again, and I want you to, again, that's kind of the interesting and important part of this question, because when we do say and set up our equations, the momentum before equals the momentum after, we are never saying that that is true for a single object. We are saying it for the system. That's why we often have like the momentum of the first one plus the momentum of the second one before the collision equals to the momentum of the first one plus the momentum of the second one after the collision. So it's a whole system of objects. Whereas it sounded like to me, you just, even though you knew that, doing maybe the homework and the video and even the test, when it came to this question, you just focused your attention on a single object and go, well, no, for a single object, you can't. And you're right, for a single object, you can't, but for a system of objects, you can.
So speaking like very simplistically, if an object has a velocity, it also has momentum and kinetic energy. That like,
Yeah, for a single object, right. Going back to these three equations, if
right.
this number right here is not a zero, and you're only talking about one object, then this number would be either positive or negative, but still not zero. Right. And this number would always be positive. So yeah, a single object with velocity would have momentum, and it would have kinetic energy, which is what was going on in your head. So your head was right in the sense that a single object, it was just limiting yourself to a single object.
Okay, yeah, thank you so much. That clears things up. Yeah, okay, I'll probably see you next Friday. I'll
okay.
Do some more stuff.
Right.
Thank you.
All right, take care. I'll switch back over to the chat. If you want to ask anything, Zach, whoops, shoot away. Let's see. Or if you just want to kind of develop a question, that's fine too.
I think for me, what I was probably going to end up doing was just trying to work through those problems while this is open, and then if I encounter something, then I would ask.